one more homework to go over from 6.3. So let's do number 6. Yeah, some of these problems, I apologize, are a little bit long. The numbers are rather big here. So, but this one is not too bad. So they give us the equation already. 1/10 q double prime plus 3q prime plus 100q is equal to 5 cosine t 10t minus 5 sine 10t. Okay. They ask for the steady state, but let's look at the problem in total here. Do everything a little bit. It's not that much work. The homogeneous is always rather quick, right? Because it's just basically solving the characteristic equation. Okay, so step 1, the complementary homogeneous. Yeah, so they gave us this equation, right? So what this means, of course, is that we would have these numbers here. We know what these mean, they stand for. So this 1/10 would be the inductance. 3 would be the resistance, and then 1/100 would be the capacitance. Okay, that's just a weird thing, but this 1/c there. But okay, they give us the equation, so we don't have to think too much about that. So our homogeneous one is just this one, and perhaps, I don't know, I am not so fond of these 10s here, but okay, let's leave it that way. Well, no, since I have to solve an equation, I don't want some coefficient there, so I'm going to multiply everything with 10. So q double prime plus 30q prime plus 1000q is 0. But yeah, well, so we have now a characteristic equation. Let's use z as a variable. Z squared plus 30z plus 1000 is equal to 0. You could try to factor it. It won't work. You let me do quickly again. No, let me not do that. Let's do the quadratic formula. So the quadratic formula, that would be z would be minus 30 plus minus 30 squared is 900 minus 4 times 1000 divided by 2. So that is 4000 minus 900. So that is minus 30 plus minus that would be 3100, right? Minus 3100. That's not a nice number, but okay, we know that it cannot always be that lucky. So plus and minus, there's an I. There's 100 in there, so the radical of that would be 10. So 10i, and then inside the radical would be 31 divided by 2. You can divide everything by 2. That makes it a little bit easier. Minus 15 plus or minus 5i radical 31. So this is again two complex numbers, and so we would have this is lambda plus or minus omega I, right? So omega is 5 times 30 radical 31, and lambda is minus 15. So we know that the homogeneous solution would be e to the minus 15t, and then we have a cosine 5 radical 31 t plus b sine 5 radical 1 t. Okay. And so we have this 5 radical 1. In the case of springs, we would call that the natural frequency. I don't know whether this is also the terminology like electrical engineers would use, but we could call it the natural frequency of that circuit, right? This is a circuit when there is no battery that adds some extra juice to it. But that's not the question. The question is, what is it? What did you get if you have extra juice given by this kind of pulsating battery power? Okay, again, this is also a sign. So we know that so our solution will be, the frequency is 10 here, so we will also have a solution that is a linear combination of cosine 10, 10 and sine 10, 10 t, 10 t, and the only thing that we sometimes have to worry about is is that not already a solution of the homogeneous one? But we see the frequencies are different, so we don't have to worry about that. So okay, so we propose the particular solution. We propose it to be, I'm going to reuse A and B. A times cosine 10t plus B sine 10t. Okay, so the derivative, which is, by the way, the current, and that's actually what they asked, so keep that always in mind. This kind of question, they want not the Q, but the I, the derivative of Q. So we take derivatives, minus 10a sine 10t plus 10b cosine 10t, and then Q double prime is minus 100a cosine 10t minus 100b sine 10t. Okay, and so now we plug this in. We could plug it in here, but since I see that the 10 cancels with the, I have a 100 there, right? So it's going to make the numbers a little bit smaller. So I'm going to do 1/10, right? We just copy everything, minus 100a cosine 10t minus 100b sine 10t. And then the next coefficient is 3, right? Plus 3 times q prime, yeah? Plus 3 times minus 10a sine 10t plus 10b cosine 10t. And then 100, right? Did I get this? I hope I don't want to make mistakes here. Get the numbers right, yeah? Because I tend to always copy things wrong. Okay, so I think I got it right here. And so 100 times a cosine 10t plus b sine 10t. That's just q. Okay, so, and this, what is this? Well, this is to be equal to the right-hand side, to the forcing function, which is, where's the forcing function here? 5 cosine t minus 5 sine t. So minus 5 cosine t, 5 cosine 5t, sorry. 5t, right? The frequency was, no, 10t. 10t, yeah, I don't know. 10t minus 5 sine 10t. Right, okay, of course, everything is cosine 10. Frequency is 10 everywhere here. So what is the coefficient of cosine 10t? These are the only two terms that are involved here. So what's the coefficients? So that's the green things, right? We have this one here. We have this one here, and we have this one here, okay? So let's get it. Be careful, there are always some numbers in front here. So 1/10 minus 100, so it's minus 10a. This would be minus plus 30b. And then this would be up 100 plus 100a. And that they said was equal to 5. And what's the coefficient of sine 10t? Let's do that in blue. So there are these three blue guys. And of course also this guy. So that would be minus 10b, minus 30a, and plus 100b, and that would be equal to negative 5. Okay? So what can we do here? Well, so we get 90a plus 30b is equal to 5, and 90b minus 30a is equal to negative 5. So we see the method of elimination works pretty well. If I multiply this with 3 and add it up there, okay, then the a's will cancel. So the a's will cancel, then we have 270b, that's from the bottom, plus 30b just the top, and then we have minus 15 plus 5. Okay, so this is 300b is equal to minus 10, so we see that b is equal to minus 10 over 300 is minus 1/30. And then the other one, I can plug this in now, say in, I don't know, in this one here. So I plug this one in there, I get 90a plus 30 times minus 1, 30 is 5. So that is 90a minus 1 equals 5, so 90a equals 6, so a 6 over 90, which is 2 over 30, no, sorry, is 1 over 15. Okay, let me quickly check that these are the right numbers, that I don't make a silly mistake again, which I am prone to do so often. So we have oh, okay, but right, sorry. Yes, I should be putting this in here, right? I should look at here because they ask us what is the particular solution for the current. So it's not Q that we want, but the derivative. So we should plug in the values of A and B in this. So that would be minus 10 times A, which was 1/15, cosine, no, sine then, sorry, sine 10t, sine 10t, and then the other one would be 10 times b, that would be minus 10 times over 30, b, that's b, right, cosine 10t. So we see that we can cancel here, this becomes 1/3 cosine 10t, and this becomes minus 2/3 sine 10t. And I think, yes, now it's correct. Okay. Okay, so that's the particular solution, what they call the steady state for the current. Now, what is then the general solution for the current? Of course, we should add then the homogeneous solution, but this homogeneous solution, it is Q. So we would have to take the derivative of this to find the general solution for the homogeneous current, and then add the both. The same thing. We can add. When we can add the Q's, we can also add the I's because it's just derivatives of them. Okay. So since that they don't ask, and it's get a bit ugly because of this, we have to do this chain rule, and these ugly numbers going to come out. So let's not bother this. But that could be, for instance, part of the quiz that I asked you to do this, right? If the numbers are a bit nicer. So okay. So that's the solution for this one. Okay. Yeah. So perhaps I should. So remember, I just want to say, I'm not going to put it here, right? But if you would take the derivative of this thing, you would have still this e minus 15t here. And so in the limit, this would be 0 if t goes to infinity. That's why this is somehow a small effect that is on the circuit. But after a while, the circuit is just going to vibrate in this way, because it has this steady flow of energy coming, electricity coming in, right? That's why it never peters out. If you look at the homogeneous solutions, you saw that I forgot to point it out, but go look back at the solution, you see that this very quickly peters out and becomes 0. There is no current, or there's no charge or no current anymore, because remember, if you think about springs, this guy here is the dampening. So there is a dampening. If you think of this as, instead of a circuit, as a spring, which we know this analogy we can make, then this is a dampening. So there is without this, we would have a fluctuation, like a sinusoidal solution. The circuit would keep producing, and then negative current and positive current, so the current would switch, so you get this kind of AC circuit. But if you have a dampening, then this effect goes away right away. But that's homogeneous. Since we now add there's some new impetus coming from it's not free anymore, it's forced, that guarantees that there is actually what we call the steady state, that after a while, this is how the frequency starts behaving, which again is kind of an alternating circuit, right? Because these numbers are going to go from positive to negative and so on. Okay, that's all I want to say.